Let's begin our study of markets with monopolistic competition by looking at a model of a monopoly that does not engage in price discrimination. And I'm going to sketch first the basic model for you. So as before, the model has two parts. It has a model of the consumers, which is basically going to be just as before. There are going to be C consumers. Each consumer has a utility function over Q and M, which is quasi-linear, just as before. And we're going to assume that every consumer has a WI endowment of the M good. We're going to assume that they are price takers. And importantly, using all of the methods that we have developed for the case of perfect competition, all of that is going to allow us to derive the aggregate demand function as a function of the price for the market, just as before. What has changed now is the producer side. Now the number of firms is only one. There's only one firm, and who's not a price taker. And that is critical. In particular, this firm knows the aggregate demand function, or equivalently, the inverse demand function for the market. It has cost, a cost function Q, with decreasing returns to scale of some form, and it picks quantity. The quantity is going to produce, taking into account the impact in market prices. Let me emphasize already how different this is. Before, the firms were price takers. Now, there's only one firm, and it's going to have the power to change market prices. And in particular, because it's not the demand, it's going to fully internalize the effect that changing the quantity that it wants to sell has on the market price that its product commands. Now let's look at the problem of the monopolist. It's going to want to maximize over quantity greater or equal than zero its profits, just as before. The key thing is, what are the profits now? It's going to be PD of Q times Q minus the cost of producing Q. Notice that this is, as before, revenue minus cost. Those are profits. What has changed is what is the definition of revenue. And it's important that we understand why it has changed and how. Before, this was just P, the market price, times Q. Now is this inverse demand function divided by Q times Q. Let's understand why. So I'm going to do a diagram here. The monopolist knows that it's facing a demand function with an inverse demand curve, PD of Q. And basically, you can think of PD of Q as the market price that the monopolist can charge for any quantity and still sell all of these units. So therefore, what the monopolist asks is, what quantity should I produce given that I'm going to be able to charge PD of Q? So it's fully taking into account how, as it increases the quantity, for example, the price goes down. Now, what are the first order conditions for this problem? Well, it's going to be as before. First, let's do it for an interior case. Marginal revenue at Q equals marginal cost at Q. Now, the key question is, what is marginal revenue? Before, it was just P, the market price. Now it's going to be given by Q times dP of dQ, and this is of the inverse demand function, plus PD, and this is just C primer. So notice that the marginal revenue has changed. Notice that this is negative since the demand function is downward sloping, and basically it has a different shape as before, and we're going to explore the consequences of that in 1 second. Notice also that for a corner solution, this just look as the marginal revenue at zero. So this term evaluated at zero has to be less than the marginal cost, less or equal the marginal cost at zero. And also notice that the second order conditions are satisfied if the marginal revenue is less than 0. And this should be very intuitive to you from previous work that we have done, especially in Unit 1. If the marginal revenue is negative, the problem with the monopolies can be plotted like this. You have a marginal revenue curve that is decreasing in Q. Sorry, what I should have said here is if the marginal, I apologize, if the marginal revenue decreases with Q. So you have a marginal revenue curve that looks like this. Let's say you have a marginal cost function that is flat or not or increasing, and then it's clearly that there is a unique solution for the monopolies which has this value. This is QM, by the way. Now the intuition should be obvious. If you start at 0, you should produce the first unit because the marginal revenue exceeds the marginal cost. You should produce the second unit because it's the same, and you should keep going up to the point with marginal revenue equals marginal cost. So basically the same ideas about optimization that we have been seeing all along still apply for the monopolies, except that the marginal revenue looks different. Let me describe graphically what the equilibrium looks like. You have quantity, you have price, you have the inverse demand function that looks like this. And as we will see in the examples, and also as you can infer from the definition of marginal revenue, the marginal revenue curve basically looks something like this. It starts at the same point and goes below it, decreasing. So it's going to be the marginal revenue curve as a function of Q. Then let's say you have the marginal cost curve, is something like this. And if the monopoly is producing an interior allocation, producing a positive amount, and by the way, when the QM as the quantity produced by the monopolies, what we have is the following. The monopolist picks this quantity, but please notice that this is not the equilibrium price. The equilibrium price is this, the price that the market would bear, the maximum price that can be charged, and still get that amount produced. So this is the amount that is the price in equilibrium. Now it's illustrated to compare how is this different from the case in which the monopolist had acted as a perfectly competitive firm. In that particular case, we know that this would have been the supply curve of the firm. So this would have been the quantity in equilibrium if the firm had been competitive, and it would have been the price on equilibrium if the firm had acted as a price taker. So in other words, the monopoly introduction of the switch from the competitive behavior with this, other things being equal, the same firm, the same cost function, increases the quantity produced and increases the equilibrium price. Let me give you some intuition for why marginal revenue tends to decrease with Q. So let's look at our diagram of the inverse demand function. And let's do the following. Suppose that you start at quantity Q, and we know that we are at that price, P. And now consider increasing the quantity to Q plus DQ by a tiny amount. We know that total revenue is gonna change. Before it was this area, now it's gonna become the area of this rectangle, because the price is gonna decrease to this. Okay. Now let's see what is the impact in total revenue. Well, the increase in the quantity increases revenue approximately by plus P, whatever the price P was there, DQ. Now let's look at the size of this area. Is approximately Q, P prima, which is a decrease in price, DQ. Notice that P prima DQ is the approximately change in price. So this is DP basically. And notice that DP is less than 0. So this is a positive term, this is a negative term. Now what is the change in marginal revenue? Is going to be P times DQ minus Q prima, all of this, sorry, plus Q prima, all of this by DQ, where this is negative and this is positive. Now look at the following to understand why marginal revenue goes down. This term dominates when Q is small. So let's say when it's approximately 0. Why is that the case? When it's very small, the price is very high, so this term is very positive, and this term is approximately 0, so Q is 0. Now, this term dominates when Q is large. Let's see why. When Q is very large, the price is approximately 0, so this term goes to 0, it goes down, and as Q increases, this term becomes more and more negative. So that pulls the marginal revenue down. Now, let me emphasize, this suggests there's a very robust phenomena that marginal revenue will go down, but let me highlight that it's not always the case. So it cannot be guaranteed that marginal revenue tends to decrease with Q. And you can basically construct cases in which that is not the case. And if you want an intuition for why it is the case, one particular simple way of constructing is remember that when you look at the aggregate demand function, sometimes you have kinks like this, in which different individuals start coming in at different points, and that can very easily produce marginal revenue that is locally increasing. So far, the analysis have ignored the issue of fixed costs or semi-fixed costs. How do this change the problem of the monopolist? It's very easy. What you do is do 2 steps. Step 1 is compute the profit of the monopolist, the best it can do, conditional on entry. Step 2, you compute the profits conditional on not entry. And then you choose the solution with the highest profits. In other words, even if there are fixed costs, if conditional on entry you do better than non-entry, you entry and you pay either the fixed cost or the semi-fixed cost, otherwise you don't. And we're going to explore this in more detail in the practice problem. We have seen from the first welfare theorem that competitive markets generate Pareto optimal allocations. Let's see what happens when we have a monopolist without price discrimination. Let's look at our equilibrium diagram. We have the inverse demand function. We have the marginal revenue curve. We have the marginal cost curve. We know that the optimal quantity is this. And we also know that the quantity produced by the monopolist is this. Now, it should be easy to see that the deadweight loss in this case is this area. Why? Because the quantity produced by the monopolist is below the optimal quantity, and basically by increasing production by all of these units, we can obtain social benefits, marginal benefits that exceed the marginal cost of production up to this point. Now, the exact formula for this area is equal to the integral from the quantity of the monopolist to the optimal quantity under the inverse, between the inverse demand function and the marginal cost curve, dq. Let's get some intuition to try to understand why the first welfare theorem works for competitive markets, but not in the case of the price of the monopolies without price discrimination. So let's compare the case of the competitive market and monopolist that we are studying here. So in the competitive case, what we had is that every individual, by the way, this is just for intuition, look at interior solutions, because this is just, it's not a rigorous analysis, I'm just trying to pass you an intuition. Every individual equated their marginal benefit with the market price, and this was driven by their utility maximization, and every firm equated the price with their marginal cost, and this was driven by price taken plus profit maximization. Now, together, this implies that marginal benefit is equal to marginal cost for all firms, and this implies Pareto optimality. In other words, the invisible hand of the market guided the equalization of marginal benefits and marginal cost, which is what is required by Pareto optimality, through the fact that everybody equates this marginal benefit with price and marginal cost with price in order to maximize their well-being. Now, what happens in the case of the monopolist? Well, the consumers do the same thing. They try to equate, or they equate marginal benefit to marginal cost, again, by utility maximization. And the firms still want to equate, wants to maximize profits. But the problem is that what they do is they they equate, marginal revenue equals to marginal cost. This is what monopoly plus a profit maximization gives you in this case. And the problem is that the marginal revenue, as we have seen, is always less than the price. So this implies that in equilibrium, marginal benefit of the consumers is greater than marginal cost, which implies Q of the monopolist is inefficiently low. In other words, the invisible hand of the market, when individuals can influence prices, does not guide you towards the conditions required for Pareto optimality. Finally, let's do a distribution analysis of the equilibrium generated by the monopolist case in comparison with the behavior in the equivalent competitive case. So we have again our equilibrium diagram. We have the inverse demand function, the marginal revenue, the marginal cost, and I'm going to highlight several things. This is the quantity at the competitive case. This is the quantity of the monopolist. And I want to highlight, this is the price of the monopolist, remember. I want to highlight several areas here. Let me call them A. This is all of this triangle here. B is the rectangle. So basically ignore the marginal revenue curve when labeling this area. C, D, E, and F. And let's do our usual table, especially with a focus on producer surplus and consumer surplus at competitive case and at monopolies. Now let me emphasize that the competitive case assumes basically that there is one firm with exactly the same cost function is just behaving competitively. So in the competitive case, the producer surplus is C plus F plus D. That should be obvious. And the consumer surplus is A plus B plus E. Now what happens when we shift to the monopolist case? The consumer surplus just becomes that. So it goes to A, and the producer surplus becomes all of this. So B plus C plus D. Notice that if you do the difference, you get that consumer surplus is going down by minus B plus E. So the consumers are clearly worse off as a group if you only take into account their effect on them and consumers, not as firm owners. And you have that the producer surplus is going up by B minus F. Now we know that B minus F, this is very important, has to be greater than 0. How do we know that? Because the firm could have replicated the competitive outcome by just choosing Q star. Therefore, the fact that it didn't do that, that it chose a lower quantity, means that its profits went up, which means that B has to be greater than F. So basically, there is a redistribution of consumer, there is a deadweight loss, but there's also a redistribution of consumer surplus to producer surplus. Now, that redistribution effect is not important if the firms are owned, if the firm is owned equally by everybody, but that is not typically the case. What you have typically the case is that the firm ownership is concentrated, so you have redistribution of social surplus if there is concentrated firm ownership.